Assalamualaikum. We from Group 9 from Section 2 will present our project about case study. I am Muhammad Nur Irfan Mido Azmi, the leader of this group, and these are our fellow members. The first one is Azad Mukris, and the second one is Muhammad Bazli, the third one is Muhammad Faiz Saikal, and last but not least, Zaid Asani bin Muhammad Khairi.
For the introduction part, this weekend, a club from Selangor held a tour in the district of Muar. According to their plan, they will first spend the night at Homestay Parit Bugis upon arrival. The next day, they will begin their tour of the entire Muar district. To have fun experience, they need to visit all the checkpoints along the way at once. On the provided graph, our team must determine the route that is the shortest in terms of distance in this tour. Without further ado, let's discuss the graph model. We are using the graph online to portray the problem. We construct a graph that imitates the original map in the district of Muar. So, the start graph is the result and the final graph we created using the graph online. Let me demonstrate in detail how we construct the graph using the graph online. For the first step, we use the Add Vertex tool and select the custom tag for vertex enumeration to carry out the vertex that refers to the places that Selangor Club will go through. Firstly, place the vertex where you want it to be and name the vertex like the picture in figure 2. For example, the first vertex we name it as Homestay Parit Bugis. Repeat the same process to create another vertex. Figure 3 shows the done vertices using the step 1. Secondly, we have to connect all the vertices using the Connect Vertices tool beside the Add Vertex like figure 4. To connect from the first vertex to the second vertex, you can either click at the first vertex, thus click at the second vertex to connect it, or you can select the vertex like figure 5. Then, select the weight of the edges which refer to the kilometers from one place to another. For example, for Homestay Parit Bugis to Sungai Balang is 10 kilometers like figure 6. You can add the kilometer parameter in the text above edge to indicate it is a distance and click the undirected to create an edge with no arrow. Figure 7 is the result of all the connected vertices. Last but not least, you are able to edit the vertices and edges in the settings like figure 8. For example, you can select the most preferable shape, color and the background color of your vertices like figure 9. Figure 10 is the result of edited vertices to make the graph looks more appealing and charming.
Next, we move into the graph description. Based on the problem statement before, we have determined that weight graph is the best type of graph to find the shortest road in terms of distance in this tour. A numerical weight on the edge on this graph will represent the specific distance between the nodes, and the nodes will represent the checkpoint along way this tour. From the distance that have been represented by the weight, it will allow us to make an algorithm calculation to find the shortest road distance for the entire Muar district. Algorithm calculation will facilitate us to find the shortest road tour because it will start from the node Homestay Parit Bugis and reaching all of the nodes, and path with the minimum of total weight will be considered as the shortest road.
Thank you, my friend, for the great explanation just now. Now, we need to demonstrate how an algorithm is used to solve the problem. First of all, we need to define a problem. So, the problem is we need to find the shortest path in terms of distance by visits all the checkpoints along the way once. Next step, we need to devise a plan. We solve this problem using the Kruskal algorithm method. This is because the generated path will not create a cycle. Furthermore, it will take the shortest path to touch all the verticals that have been provided in the graph.
Okay, we move on to carry out plan. The first step, we need to assume all the vertex or the place at the first graph, we need to change it to the second graph, just like at the diagram, to make it easier to solve. So, we use Kruskal algorithm to solve this problem. The shortest edge at this graph is 2, which is at vertex 11 and vertex 10. So we need to highlight it. Then the next shortest edge is at vertex 2 and 3, which with a length of 6. So it is highlighted. The next shortest edge is at vertex 4 and 6 with a length of 7. So it is highlighted. For the next step, they have 4 same weight, which is 10. So we choose vertex 1 and 2 arbitrarily. So it is highlighted. We highlight with the red color at vertex 1 and 3 because if you choose that edges, the path will be in a cycle. So we cannot use that path again. Same as the previous step, also they have a same vertex with a length of 10. So we need to choose a vertex arbitrarily and then highlight it. So we choose vertex 3 and 4 for this step. Next one, we choose 5 and 6 to be highlighted. The next shortest edge are at vertex 9 and 10. So it is highlighted. The edge at the vertex 9 and 11 has been highlighted with a red because the path will cause the cycle. The next shortest edge is at vertex 6 and 7. So it is highlighted. We highlight in the red the edge at the vertex 4 and 7 because the path is already exists. So it will cause a cycle if we highlight it with a green. The next shortest edge are at vertex 7 and 8. So it is highlighted. The edge at the vertex 4 and 8 has been highlighted in the red because the path is already exists and it will cause a cycle. Finally, the process finished with the edge at the vertex 8 and 9 with the length of 16 and the shortest part at this graph is found.
The last step is the checking process. Based on what Irfan explained just now, let's check together if the solution that Irfan made is true or not. On the slide, we can see there is the first way, which is the way that the most shorter that we have find. The road start with homestay Parit Bugis, Sungai Balang, Seri Menanti, Parit Jawa, Parit Bakar, Bakri, Pagoh, Air Hitam, Lenga, Bukit Kepong, and finish at Museum Bukit Kepong. The sum of distance that has been counted during this trip are 121 kilometers. Next, the second route that they can take is start from homestay Parit Bugis and finish at Pagoh. The sum of distance that has been counted during the trip is 157 kilometers. Last but not least, the third road that they can take is start from homestay Parit Bugis and finish at Air Hitam. Then, the sum of the distance that has been counted during the trip is 179 kilometers. That's all from me.
Taking everything into consideration, the shortest way starts from homestay Parit Bugis and finish at Museum Bukit Kepong with 121 kilometers distance. In these circumstances, there are a lot of good impacts that can be obtained using the least distance, such as being able to save time from going for a long distance. On the other hand, it can reduce the cost of fuel consumption. On top of that, the Selangor Club can finish their tour earlier. Clearly, the shortest parts provides a significant impact for the Selangor Club journey. That's all from us. Thank you.